Okay, so welcome to the second part of this course, and this course is about data structures as we have mentioned it on multiple occasions. So let's get started. This is what we did in our last lecture. So in our last lecture, we reviewed the fundamental concepts of object-oriented programming. We talked about encapsulation, abstract data types, object, classes, state and behavior. We also talked about inheritance and how useful a mechanism it is for code extension. We talked about polymorphism, what is polymorphism or what is polymorphic behavior, and we talked about virtual classes, like how do we use polymorphism or how do we enable polymorphic behavior in classes using not virtual classes, virtual functions. We also talked about like pure virtual functions and abstract classes as well, but we talked about all of it in our last lecture. This lecture is about data structures. Okay, so what are data structures and why do we need to have data structures? We'll briefly talk about this. I guess we have mentioned it on multiple occasions before. Like there are plenty of, in fact, like computer programming and computation is all about data processing. So you have data and you want to process that data and get some information. Okay, and that is what we do almost all the time. So in order to process data, you need to store that data in ways which would make its processing easier and efficient. And in order to do specific forms of processing, you need specific forms of data structures or ways in which you should organize data. For example, like you're all aware of you all have used Microsoft Word or any computer application for that matter, and you are aware that almost all computer applications, they give you the facility of undoing your last action. Okay, so you can press Control plus Z and you can undo your last action. So how do these softwares do that? How do and what happens when you press Control plus Z? So when you press Control plus Z, your last action is undone. Your latest action, the latest action that you did, that is undone. If you press it again, then the second last action. If you press it again, then the third last action. So what happens is that behind the scenes, the software is maintaining a data structures of which stores all the actions that you perform, and that data structure is called the stack data structure. Now the stack data structure is, it's just like a stack of dishes. If you go to a buffet in a restaurant, so there are plenty of plates and those plates are stacked on top of each other, and you can only pick a plate from the top. When you pick a plate from the top, so the plate that is after, that is below that plate, it gets to the top. Okay, and new plates, when the plates are washed, so they are put on the stack as well, on top of the stack as well. Okay, so data entry and data removal on a stack, it takes place at one position, that is the top of the stack. Okay, so you are aware of that. I hope you're aware of that. And that basically, that data structure stack, it is also called a last in first out data structure, because the latest entry on the on the stack data structure, that is the entry which is going to get off when you perform the read. Okay, that is the data entry that is going to go off the stack when you perform a read. Okay, so it is useful. The stack data structure is useful in many ways. So when you start, for example, working in a Microsoft Word document and you start typing text and you do different actions, formatting and inserting tables and images, so all your actions, they are pushed onto a stack, they are placed on a stack. So the first action that you performed, it is placed on the stack the very first time you perform that action, and then the successive actions, those actions are placed on top of that action subsequently, one by one. So the first action that you perform, it basically uh, becomes the bottom of your stack, and the latest action, the very latest action that you just performed, it becomes the very top of your stack. And when you start undoing your last actions, so the latest action which is at the top of the stack, that is undone first, then the second last, then the third last, and so on and so forth. Okay. You must be aware of another example like these pistols. Like they have a magazine, and that magazine is basically a spring-loaded magazine, and usually bullets are inserted into that magazine from the top. So there is one there is a space through which a single bullet can get in or get out. So that space at the top of the magazine is used to insert bullets. So the first bullet, the very first bullet that you insert into the magazine, that would settle at the bottom of the stack. And then when you insert more bullets into the magazine, so the last bullet that you enter into the magazine, that bullet would be at the very top of the stack, at the very top of the stack. So stack is like, if you want to imagine it, it is something like this. So this is say our magazine kind of thing, okay? And this is a spring loaded magazine. So this is some metal piece, and below it we have a spring. Okay, so assume it to be a spring. So you start inserting bullets here. Okay, and when you insert a bullet, you apply force, and that force pushes the spring downwards, and then there is some piece of metal which basically holds this bullet inside the magazine. Okay, so then you start inserting more bullets, and after some time, this is what the situation would be. So the spring is now compressed, and there are bullets here. So this is say a bullet, this is another bullet, this is another bullet, this is say another bullet. This is not a very peaceful example, but nevertheless maybe people can relate to this example. So these are all the bullets. This was the bullet that was entered or pushed into the magazine for the very first time. This is number second, this is number third, this is number fourth, number fifth, and number sixth. When we start firing off these bullets, this is the first one that is going to go. Okay, the bullet that was entered, inserted in the very last, that bullet is going to be fired first. Okay, and then this one, number 5, then this one, number 5. So this is the top of the stack. This place is called the top of the stack. Okay, so data is pushed onto the top of the stack, and it is popped off the top of the stack. So these two operations are defined for a stack. Pushing something onto the stack, this is basically insertion of new data, and popping something off the stack, this is basically removal or deletion of data from the stack. Okay, so these are, and this stack is a very useful data structure. So we just said that this undo facility that you have in almost every application, it uses a stack behind the scenes. Similarly, if you are using a browser and you enter, you visit a web page, and then you click some link there, and then you enter a new web page, and then you click another link there, and so on and so forth. So if you want to go back to the page that you visited most recently, so you have a back button in the browser. You have a back button in the browser. Now that back button, in order to implement or give you this functionality, the browser has a stack behind the scenes. The browser uses a stack behind the scenes. So whenever you visit a new page, it pushes a URL, the URL of the new page, onto the stack. Okay, so if in that page you click another URL, so it will get that URL and push that one onto the stack. Okay, so then uh, you can use these URLs which are stacked together on a stack, and you can basically revisit the pages that you visited before or earlier. Okay, so that functionality is also provided by a stack. Similarly, in programming, like you write these very long expressions. For example, you say y is equal to x multiplied by 2 plus 3 divided by z, okay, and then multiplied by something minus something, okay. So you use these expressions. Now how does your compiler evaluate these expressions, okay? So in order to evaluate these expressions, your compiler relies on stacks. So these expressions are first converted into, these are infix expressions. Infix expressions are those expressions where the operator is between the operands. So these are infix expressions. So the compiler first converts these expressions into postfix or prefix forms. Postfix expression are expressions. Postfix expressions are expressions in which, like, you specify the operands first and then the operator. For example, 3 plus 4. This is infix of expression. We are used to infix expressions, okay. So these are the two operands and this is the operator. We are adding 3 and 4, so this is how we write 3 plus 4. And this is the postfix form. You first write the operands 3 space 4 and then addition operator. So this is the postfix form of this notation. Now this notation is, postfix form is slightly better than this one. Why? It may not be that easy for us to comprehend, but this expression does not require any rules of precedence, okay. So you can evaluate it directly, but for this one you need to remember the rules of precedence and all that, okay. So in order to convert an infix expression into postfix expression, you need stacks, and then in order to evaluate a postfix expression, you also need stacks, okay. So stacks are very useful components, very useful data structures, sorry. Then there's another very famous data structure, that is queue or Qatar, okay. So queue, you should know what a queue is. Whenever there is one service provider, for example, you go to a bank and there is, say, one ATM, and there are many people who want to use that ATM, okay. So what would people do? Definitely only one person can use it at a time. So while that person is using it, the other people, they queue up, they stand in a line or a queue, okay. So a queue is basically a data structure, which is a first in first out data structure. So in the queue you will get service. The first person who arrives in the queue, that person gets service, okay. So in the queue, like, people are served at the front of the queue. When a person is served, that person gets out of the queue, okay. So data is removed from at the front of the queue, and new people arrive at the rear end of the queue or the back of the queue, okay. So this is where new people arrive. So data is inserted in the queue at the rear end or at the back of the queue. So a queue is also a very important data structure. In real life as well as in computers, uh, in networks, for example, computer networks or mobile networks. So we are sending text messages and emails, and all this data is being transmitted on computer networks. So the computer network is not always free to transmit data. So whenever, for example, if this is a switch, uh, which basically forwards your data to another switch and all that. For example, if this switch receives some data, you are sending some data and that data is received by this switch, okay. So this is the data that you sent, and right now the switch is busy. It is already sending some data and cannot send this data, so it needs to store this data temporarily. So these switches have memory in which they can store this data temporarily, okay. So those memories are basically RAMs or flash memory or something like that. So those memories are used to store this data temporarily. So if a new data arrives, that data is basically stored in a queue, okay. So the data that arrived first, that data will be sent first, okay. So basically these switches, they have queues, they have data structures which operate as queues, and these queues are basically used to store your emails or your text messages temporarily, and whenever the switch can transmit, they start transmitting the text messages or the emails. The ones that arrive first, those are transmitted first. So queues are basically first in, first out structures, FIFO structures. First in, first out. The first person who gets into a queue, that is the person who gets out of the queue. Whereas in stacks, this is not the case. Stacks are last in, first out. Okay, so the person that gets in at the end of at the very last, okay, जो सबसे आखिर में आता है वो सबसे पहले स्टैक से निकलता है, ठीक है. So there are other data structures, for example trees, and those data structures are also very important. They can also be used for evaluating expressions, for storing data, so that it can be searched quickly and all that. Okay, so basically data structures are used for storing data so that it can be processed much more efficiently and quickly. So we'll begin with the very simple data structure, and that data structure is the linear list. Is the linear list. So you can imagine the linear list to be, if I have to make a list of all the students in this class. Okay, so the list of all of you guys, so that can be a linear list. Now when I'm making a list, I have that the list is basically an ordered list. Okay, it has some order. So that order would come on some basis. So I can make a list and I can order all the items in that list based upon your registration numbers, or based upon your class numbers, or based upon the first alphabet of your last name or your first name. So there can be plenty of different basis on which uh, we can specify order for a list. Okay, so that is what a linear list is. It is linear, so that means you have a single column of items, and it is a list, which means that all the items in that list have some order. Okay, so there is some order. There is something which comes first, and then there's something which comes second and third and fourth and fifth. There may be some basis for that order. Okay, so we are going to talk about linear list, and we are going to look at the array based implementation of that list. Now I will show you some sample code which basically does array based implementation. I may not do this implementation in this session. I may leave it for you as a homework or assignment or practice. You can do that. I'll do the other implementation of the linear list, and that is the linked list implementation of the linear list. Okay, so that is, I guess, something new and more important. This is very simple. You can also do it. All you need to do is you need to understand how the list works. The recommended textbooks, I have mentioned this before as well, for this part of the course is Data Structures and Algorithms in C++ by Michael T. Goodrich and Roberto Tomasia. This book is also available for other languages, for Java as well. I guess the latest edition available is second edition. I'm not sure if we have a copy in the library or not, but there are definitely copies available in the market. Similarly, the other book, very good book on data structures, is Data Structures, Algorithms, and Applications in C++. This is by Sartaj Soni, I guess. So this is also a very good book. I guess the latest edition of this book is second edition. The slides that I'm using for this part of the course are basically based are for these two textbooks. So uh, the slides basically are, I guess they come from the official website or official slides for these textbooks. Okay, so let's get started. So first of all, some definitions. Again, these definitions they vary from book to book. I guess this one comes from the second book that I mentioned. Uh, if there is a change of terminology that I'm using in my code or something like that, so I'll definitely mention that. But let's get started here. So first of all, we'll introduce the term data object. Now, what is a data object? A data object is basically a set of instances or values. For example, So these are data objects of type Boolean. So what are the values or instances for this data type? So we have false and true. So this can be a data object. This here can be a data object. Similarly, we can have digits 0, 1, 2, 3, 4, 5, 7, 8, 9. This can be a data object. Okay. We can have alphabets A, B, C, D up to Z, capital and then small. We can have strings A, B, and then A, B, A, C. So all possible combinations of these alphabets, they can be part of the data object string. Similarly, we can have natural numbers, and those natural numbers are, say, starting from 1 going up until positive infinity. We can have integers, we can have real numbers, we can have any set of instances or values, we can call it as data object. Okay? Now, an individual instance like this, it can be primitive or atomic. Primitive or atomic means like this is the most basic part of it. Primitive, or another term for it is atomic. Now what is an atom? So the original definition of atom was that it is the smallest particle of matter which cannot be subdivided any further, which was not true, but because there are so many subatomic particles inside the atom, but still we use the term atomic for something that is the smallest in size. Okay, so an individual instance of a data object can be atomic, like false and true. These cannot be broken down, false and true, further. Similarly, a 0, it is atomic or primitive. 1, 2, 3, these are atomic or primitive. These cannot be broken down any further. This is composite, 11. It has two digits, 1 and 1. This is also composite, 10. It has two digits as well. And these two digits, like, they have different significance. These are ones and this is a 10. So they have different significance. Okay. So an element is the individual component of a composite instance. So what do we call an individual instance? Is either primitive or composite. So individual instance can be either primitive or composite. And what is an element? It is the individual component of a composite instance. So if we have a composite instance, so individual component of that composite instance we can call an element. Okay. For example, this is a composite instance, say for example, and 1 and 1, these are two individual elements of this composite instance. Similarly, this is a composite instance, and 1 and 0 are individual elements of this composite instance. Okay. Okay. Now, what is a data structure? A data structure, similarly, like, okay. Now, what is a data structure? A data structure is basically a data object together with the relationships among instances and elements that comprise an instance. So, a data structure is basically a data object which can be any set of values or instances, and then relationships among those instances, like how are those instances organized, how are they put together in that structure. Okay? So those relationships can be among the instances or among elements that comprise individual instances. Okay? So for example, these are two say natural numbers. Okay? So what is the relationship between these two natural numbers? It is that 369 is smaller than 370. 370 is greater than 369. Okay? So we have an integer, for example, an integer data object, a set of integers, and these are two instances in that set, and they have a relationship. Okay? This relationship basically gives birth to order. Based upon this relationship, these instances, they have a certain order. Okay, so relationship is important. Similarly, this is another relationship. This is one instance, this is another instance. If you add these two instances, you get another instance within the set of integers. Okay, so this is a relationship, a valid relationship. Among elements that comprise an instance, similarly, this is an element and it has these individual, this is, sorry, an instance, and it has these individual elements 3, 6 and 9. So 3 is more significant than 6. it is basically 300s. ठीक है? This is 6 tens, this is 9 ones, this is one relationship. ठीक है? The other is 3 is immediately to the left of 6, 9 is immediately to the right of 6. This is another relationship. ठीक है? So a data structure is basically a data object together with relationships among instances. So in whatever we are going to study, in the data structure that we are going to study, this is what we are going to study. Okay? We are not going to talk about relationships among elements of an instance. We are mostly going to restrict ourselves to relationships among instances. Okay? Say for example, the data structure that we talked about, say stack or queue. So in queue, say this is a queue. Okay? This is the front end of the queue. Let us represent it by the symbol F. And this is the rear end of the queue. Let us represent it by the symbol R. So new data entries arrive here, and the ones that have already arrived, they are basically here. So say this is the first element of the queue. Okay? Let us call it as Q1. Okay? This one is the second element of the queue, Q2. Why is it called the first element? Why is it called second? Because this arrived first in time. Okay, so this arrived say at 7 a.m. This one arrived at 1 past 7 a.m. Okay, this one arrived say at 5 past 7 a.m. Q3. So they have a relationship. They have a relationship, and that relationship is the arrival time. Okay, that relationship is based upon arrival time. Okay, so a queue is a data object. It has these different values. Okay, these can be any value. This can be a text message, a string. This can be a phone call. This can be an email. This can be a number. We are going to mostly implement all these data structure using numbers, but they have a relationship, and that relationship is uh, based upon arrival time. So the one that arrives first, it has a lower subscript, Q1, Q2, Q3. The one that arrives late, it has a higher, it goes to the back of the queue. Okay? So mostly we are going to restrict ourselves to relationship among instances. We are not going to go into relationships among elements of an individual instance. But this is what a data structure is: a data object which has multiple values or instances, and then some relationship among those data objects. And afterwards, we'll also say that a data structure also has operations. So that those operations are going to take place in a way so that the relationship between those instances of the data object, those relationships are kept intact. They are not disturbed. Okay? So let's get to another definition: abstract data type. An abstract data type is a collection of data and a set of operations. That is what we talked about. That can be performed on that data. So we have a data object or a data structure, and we have a set of operations. These two make up an abstract data type. Okay? These two make up an abstract data type. So an abstract data type enables us to think abstractly about data. Okay? We can think abstractly about data. Like we can imagine data taking different forms and moving in different ways or being operated upon in different ways. We can separate concepts from implementation. Yes, that we can do. Just like I hope you understand the concept of the stack data structure, the way it works, and the concept of the queue data structure, the way it works. Okay? So we can separate the two, the implementation and the concept. Typically, we choose a data structure and algorithms that provide an implementation of an ADT. So an abstract data type, it has a data structure, and it specifies algorithms which can be used to provide an implementation of the ADT, because that is what we do inside an abstract data structure. So we learn, like, if you have a stack data structure, so how can you insert new data items into the stack data structure? How can you remove data off the stack? Similarly, if you have a queue data structure, how can you insert or enqueue new data into the queue, and how can you remove existing data from the queue? Okay, so we can specify algorithms and implement those algorithms for that. Okay, now let's come to the definition of a linear list. What is a linear list? Okay, what do we mean by a linear list? Now, a linear list is a data object whose instances are of the form this: E1, E2, E3, E4 up to En. So it is a finite list. It is a finite list. Okay. Its length is say n, starting from 1 going up until n. EI is an element of the list where I can be 1 up to n. Similarly, E1 is the first element in the list and En is the last element in the list. So there is an order, like these are not just randomly put together. These elements have an order. Okay, that order can be based upon different rules. Like you can come up with rules which will determine the order in which these elements would be put together. Okay, so n is the length of the list, and E1 is the first element of the list, En is the last element in the list, and these elements they have an order. Okay, E1 comes before E2, E2 comes before E3, En minus 1 comes before En. So that is the order. When n is equal to 0, then we call the list is empty. If n is equal to 0, then the list is empty. Okay. If n is not equal to 0, then it is not empty. Examples of lists can be, so we can generate a list from anything. If we have a list of names of students, so we can generate an alphabetical list of the names of students, or we can generate a list of the GPAs of students, and we can generate that list so that the maximum value or the highest value of the GPA is at the top, and then so on and so forth. Like at the bottom, we have the lowest value of the GPA. So we can order that list in the descending order. So we can have different examples of linear list. The closest the closest data structure that you might have used similar to something of a linear list is the array, but in there we did not specify, like it was a linear array, and in there like the elements they were ordered according to the index of according to their indexes. The index started from 0 and it went up until the size of the array minus 1. So here in this list, yeah, the index always starts from 1 and it goes up until n, but like we can make changes to this rule. We can make it start from 0 and go up until n minus 1, something like that. That we can do, but this is how we define it so far. So that is the closest thing that you have interacted with to a linear list was the array. And in this class we'll look at an array based implementation of the linear list. So let's see how would that look. So this is the abstract data type for a linear list. This is the abstract data type. So what is an abstract data type? So it has a data structure. Okay, it has, this is the data structure. So what is the data structure? Ordered, finite, ordered comma finite collection of 0 or more elements. So we have a finite collection of 0 or more elements, and those elements are ordered. They have a certain order. That order can be based upon many things. Okay, but they have a certain order. Now these are the operations that we need to have for this linear list. The first operation is we need to be able to create this list, an empty linear list, destroy or erase this list, see if this list is empty or not, get the length of this list or the size of or the number of elements in this list at the moment. We should be able to find uh, the kth element of the list and return its value, or return that element in the variable x. So this would be passed by reference. We should be able to search some element. If you want to search for some value, just specify the value, and if that value exists in the list, it should return the position of that value in the list. You should be able to delete some element at a particular index or location. So this here is basically this function would delete the kth element in the list and return it in x. So you delete the element and return it in x so that you know which element has been deleted. This function basically provides you with a method to insert new element. So how do you insert new element? You insert x just after the kth element. So you specify k and you say insert x after k. And this here output, you can name it as print as well. Here they have named it output. So this basically would put the list into the output stream out. Basically we would simplify it and like you can make it print and it would print all the elements in that list in their specified order on the console screen. That is what it should do. Okay, so this is the interface. Now we look at implementation of these functions, like how you can implement these functions. The code that we are going to look at, that code is very generic. Generic means it is not for a specific type of value. We have not studied generic programming in C++, but you can replace that generic class by some data or some other user defined class. You can do that. Okay. The point is that you should know like how to implement a linear list using an array. And the only, I guess, uh, challenging functions or operations for that would be deleting and inserting. The rest of they are very easy to carry out. Okay, so how do you delete and how do you insert new items into the list? That might be a little challenging. So let's get started. How can we implement linear lists? So there are different ways through which we can implement linear list. One is array based implementation. Okay, so array based implementation means that behind the scenes we would be using an array to store the elements or to store the individual instances. Okay, so we have a data structure which has a data object. That data object has individual instances or values. Now how do you store those values? So if you store those values in an array, so that is array based implementation. Why do we call it formula based? So how do you access individual elements inside the array? So the array, like it has index starting from 0 and 1 and then going up until the length of the array, let us call it L minus 1. Okay, and the list, usually this is the array. This is how the indexes run in an array. And in a linear list, we have indexes that run from say 1, 2, and then go up until n, which is the size of the list. Okay. So how do you do this mapping? कि list का पहला item array में किस जगह पे store होगा? So you can do this mapping through a formula. Either you can make things simple. कैसे simple? जो array का index है वही list के item का index भी हो. ठीक है? So you use a simple formula के list के जो item का index है और array का जो index है, they should be the same. This is one formula. The other formula that you can use is कि लिस्ट का जो इंडेक्स है वो अरे में अगर आप उसको स्टोर करना चाहेंगे तो उसमें से बस 1 सब्ट्रैक्ट कर लें. इसका फर्स्ट एलिमेंट वुड बी एट लोकेशन 0, इसका सेकंड एलिमेंट एट लोकेशन 1. इन जनरल इसका ith एलिमेंट वुड बी एट लोकेशन i minus 1. ठीक है, इनसाइड द अरे. ये फार्मूला बेस्ड का मतलब ये कि दिस इम्प्लीमेंटेशन यूजेस अ मैथमेटिकल फार्मूला टू डिटरमिन वेयर to store each element of a list in the array. array में उसको कहाँ store करना है? तो ये list में उस element का index है और ये array में उसका index होगा. तो ये mapping किस तरह होगी? direct mapping होगी या कोई formula सा use करना है? So there are different ways to do it. ठीक है, you can make it direct, just यानी list को भी 0 से start करवा दें. ठीक है, doesn't hurt, इसका कोई नुकसान नहीं है. और यू कैन डू अ सब्ट्रैक्शन के लिस्ट के इंडेक्स में से एक सब्ट्रैक्ट कर लें तो यूल गेट द अरे का इंडेक्स. यानी ith एलिमेंट को कहाँ स्टोर करना है? तो अरे में ith एलिमेंट को i minus 1 इंडेक्स पे स्टोर करना है. दैट इज व्हाट वी मीन. ठीक है. अच्छा, दिस इज द इम्प्लीमेंटेशन दैट वी आर गोइंग टू लुक इन दिस लेक्चर, in this session. In the next session we are going to look at the implementation which is pointer based implementation. इसको हम linked list भी कहते हैं. So we use a linked list or pointer based list to implement a linear list. ठीक है. अब उसमें क्या होता है कि यहाँ तो बैकग्राउंड में आप अरे यूज़ कर रहे हैं इन ऑर्डर स्टोर दी वैल्यूज़, ठीक है। और जो वैल्यूज़ आप अरे में स्टोर कर रहे हैं, तो अरे जो है वो तो एक कंटिगुअस सेट ऑफ लोकेशंस होती है, यानी मेमोरी में वो तमाम आइटम्स जो हैं दे आर लोकेटेड कंटिगुअसली, एक दूसरे के आगे पीछे वो दे आर लोकेटेड, ठीक है। अच्छा, सो देयर इज़ एन ऑर्डर, यानी मेमोरी में भी देयर इज़ एन ऑर्डर, जिस ऑर्डर में आपने उनको स्टोर किया हुआ है। इन द लिंक लिस्ट इम्प्लीमेंटेशन दी इंडिविजुअल जो वैल्यूज़ हैं या एलिमेंट्स उनको कह लें, जो भी कहते हैं आप, we can store those items or nodes or elements. So these are different words that we'll be using. So हम किसी भी लिस्ट में जो इंडिविजुअल जो वैल्यूज़ हैं, we can call them as instances or values or nodes, ठीक है, और आइटम्स भी कहते हैं, लिस्ट आइटम्स भी कहते हैं, ठीक है, आइटम्स और लिस्ट आइटम्स। बाज़ बुक्स में या बाज़ जगहों पे यू विल फाइंड दिस टर्मिनोलॉजी एज वेल। So this is basically an individual item in a list, ठीक है, आइटम, नोड आइटम्स, लिस्ट आइटम, या बाज़ लोग उसको चेन आइटम, चेन नोड ये भी कहते हैं, ठीक है। So you can call them anything. In the array-based implementation, physically, when all these individual instances or elements or nodes or items or list items are stored, so they are stored in contiguous locations in an array, ठीक है। यहाँ पे in the linked list implementation, so these elements can be stored anywhere, ये कहीं पे भी स्टोर हो सकते हैं। हर एलिमेंट के पास in the linked list implementation, every element knows कि which element comes after me, ठीक है। So they say for example this is element 1, ठीक है। So element 1 knows कि मेरे बाद element कौन सा वाला है, how does it know, ठीक है। So ये वो element है जो कि इसके बाद आएगा। So हम क्या करते हैं कि इसका एड्रेस, इस एलिमेंट का एड्रेस, एलिमेंट नंबर 2 का एड्रेस एलिमेंट नंबर 1 में स्टोर कर लेते हैं। So in the linked list, every item that you have, it has two components. One is the data component जो कि data को store करता है. The other component is the address of the next element or the address of the next item or the next node. So that we store in the form of a pointer. So this is a pointer, this here is a pointer, and this pointer stores the address of the next item. So it knows where to go next. इस लिस्ट में अगर मैंने नेक्स्ट एलिमेंट को एक्सेस करना है, so it knows how to access that element because it has the address of that element. Similarly, this element knows कि मेरे बाद किस एलिमेंट ने आना है because it has the address of that element, ठीक है, it has the address of that element. So every element knows what comes after me, which element comes after me, ठीक है। So they can be anywhere, they don't need to be in contiguous locations, लगातार एक adjacent locations में इनका होना ज़रूरी नहीं है। एक कराची में हो सकता है, दूसरे लाहौर में हो सकता है, तीसरे पेशावर में हो सकता है, बट एवरीबडी नोज कि मेरे बाद किसका नंबर है, ठीक है, मेरे बाद किसका नंबर है। सो दिस इज बेसिकली अ लिंक लिस्ट इम्प्लीमेंटेशन ऑफ द लीनियर लिस्ट। नाउ यू क्रिएट दैट ऑर्डर यूजिंग दीज पॉइंटर्स, आपने वो ऑर्डर क्रिएट किया है यूजिंग दीज पॉइंटर्स। So this pointer tells you basically कि इस आइटम के बाद कौन सा आइटम या कौन सा नोड या कौन सा इंस्टेंस या कौन सा डेटा आ रहा है, ठीक है। तो 1 के बाद 2 आ रहा है, 2 के बाद 3 आ रहा है, ठीक है। सो दिस इज हाउ यू डू इट। Each element has an explicit pointer or link, that is why they are called linked. This pointer links two items. Using this pointer you can jump to this item, you know which item comes after me. So it creates a link between these two items. That is why it is called a linked list. Okay, so this is an explicit link that is created using a pointer. This is an explicit link that has been created using a pointer. Okay? So that is the linked list implementation. So that we'll do in much more detail. Like I'll write that code for you here. The array-based implementation, we may go over the code. Okay? If I have time, I'll maybe record another session to write that code ourselves. But I'll basically go over this code and leave the rest of it for you to figure out कि इसको कैसे implement करना है. The next thing that we can have simulated pointer that we used to do in languages जहाँ पे where there were no pointers. ठीक है, so I remember when we were programming in Visual Basic, so there we used to have simulated pointers. Simulated pointers से क्या मुराद है कि यहाँ पे for example if we have all the elements stored in an array, ठीक है, so instead of using the indexes के index number 1 2 3 4 5 उनको यूज करने से पहले we should store the index of the next element here. यहाँ पे हमारे पास यानी this is an element, ठीक है, और one part of it stores the data, so this is the data part, and the other part is an integer value, ठीक है, which stores the index of the next element. So this is the index of the next element. Let us call it I next. Okay. So this is the index of the next element. This is an integer value. It is not a pointer. Okay. So using this index, you can access the next element in this array. So if so now this is not going to be a built-in type. This is going to be a structure. You have to define this structure and then create an array of this structure and then use it in this particular form. So that would be simulated pointer. Like you're not using pointers, but simulating the behavior of the pointer. Okay, by using integer indexes. Okay. So usually we used to do it in languages where there were no pointers. In say in Visual Basic, वहाँ पे हम ऐसा करते थे. Now let's look at the array-based implementation. ठीक है? So array-based implementation में क्या है? It uses an array to store the elements of the linear list. So say these are the elements of the linear list 5 2 4 8 1. ठीक है? और इन elements को कहाँ पे store किया है? इन elements को store किया है हमने एक array में. What is the size of this list? So size of the list is 5. It has 5 elements. Size of the array is different, size of the list is different. So the array, like you create a very big array at the very beginning. You should remember now this is like arrays have certain limitations in C++. One of the most important limitation is that their size is static. They have static size. ठीक है, static size से मुराद के at the time of compilation whatever size you specify for an array you cannot change it at runtime. So the size of an array is static. ठीक है, so अगर आपको यानी you should have some idea in advance के how many items would my list have. मेरे लिस्ट में अगर फर्ज की आप समझते हैं कि 100 तक आइटम्स आ जाएंगे, आने की तवक्को है, so you should have an array of at least 200 elements. ठीक है, so 200 elements की array आप पहले से create कर लेंगे और उसमें you are expecting कि मेरे पास एक list मैं store करूँगा जिसमें maximum elements की तादाद 100 हो सकती है. So 100 items के लिए you would create an array of 200 elements. Now if it happens कि उससे ज़्यादा 100 से ज़्यादा या 200 से ज़्यादा elements आ जाएं तो then you would be in trouble. ठीक है, तो फिर आपका जो array है उसको resize करना पड़ेगा. तो array को resize करने का तरीका there is no way of directly doing that in C++. You have to do it manually. You have to create a new array. ठीक है, or then you have to copy all the elements in the previous array into that new array. ठीक है, and then you have to destroy the old array or the previous array. That is how you would do it. So the greatest limitation of array-based linear list is that the size of the array is static. ठीक है, you cannot change the size of an array at runtime. So उसकी implications क्या हैं? You start with a large array initially, so you might be wasting space, but वो ज़रूरी होता है. So you start with a large initial array. You start with a large initial array. So उसमें फिर आप जगह वेस्ट भी कर सकते हैं, बहुत कुछ हो सकता है. ठीक है, and if for example you have more data to store that can be stored in the large initial array that you started with, then you have to resize that array, and resizing it takes time. ठीक है, why would it take time? Because you have to create a new array, you have to copy all the elements from the old array into that new array, and then you have to destroy the new array. ठीक है, so that is why it takes a lot of time. So these are the some of the biggest disadvantages of array based implementations of linear lists. That's why we go for linked list based implementations, जहाँ पे array का size जो है it can change dynamically. ठीक है? So this is how the array based implementation would look of a list, of a linear list. This is an array of size maximum size. ठीक है? You create it before storing any elements into this list, and then you start storing elements into the list. ठीक है? So right now we have 5 elements in this list, 5 2 4 8 1 say. ठीक है? अच्छा, how do you access elements in a list? So we are using, in this particular case, we have this simple formula. The ith element in the list is at I minus first location in the array. So this is the first element of the list. It is at location 0. This is the second element of the list. It is at location 1. This is the third element of the list. It is at location 2. Similarly 4, 5. Okay? So we have 5 elements, and this is how you can access them. The code that I'll show you in the coming slides, it is based upon this particular formula, that the ith location or the ith element of the list is at position I minus 1 in the array. Okay, so let's look at that code. So first of all, this is the class interface. Now here we are using templates. So forget about templates. Now templates are basically like, you can have a linear list of anything. Templates are used for generic programming. Generic programming means writing generic code that can work with any type of data. Code that can work with any type of data, like you can store integer values or float or double values or string values or character values or any objects of your choice. So this code is supposed to work for any type of data. Okay? This is generic programming. Now we haven't studied about generic programming, but you, instead of class T or instead of T, you can assume any data type, like you can assume an integer data type or something like that. That won't make any difference. Acha ji. So this is the interface. So this is the constructor. In the constructor you specify the maximum list size. Okay? So that basically determines the maximum array size, the size of the array that you need to have. This is the destructor, and in the destructor, like, what you do is you basically the array that you're going to create here, that array is going to be created on the heap. We'll use the new operator to create this array on the heap at runtime. Okay, that's why we are going to create it on the heap, because we want to do it at runtime. So we are going to use the new operator to create an array on the heap, and then that array has to be deleted once this list is being destroyed. Okay, bool is empty, so this would return, this is a const function, this would return true if length is equal to 0. It would return false if length is not equal to 0. Acha. Int length, so if you want to get the length directly, you just access the length, return length. Bool find, this would find the kth element in the list and return its value in x. Okay? Search, if you want to search for a particular element, you can search for it and it would return the index. Okay? Where is it located? This is a little tricky. Here we are basically deleting the kth element in the list, and we are returning that we are returning the new linear list. Okay? The new list after this deletion, and the element that is being deleted, we are returning that element through this variable x, which is basically a reference. Okay? Similarly, if we insert a new element, so we are basically returning a reference to the list, and we are also getting this new element which has to be inserted after position k, after the element in the list at position k, and this basically outputs or prints the elements of the linear list. These are data members. This variable keeps track of the number of elements in the list. This is the maximum size of the array, and this pointer, it is basically used to access individual elements. It is basically used to access individual elements in the list. Okay? Whenever we need to do that, especially we might need to do it here or in the find and search in those member functions. So let's see how this code like is written. So this is the constructor for array-based linear list. This is the maximum list size that is provided as an argument. We set the attribute maximum size to maximum list size, and then we create the array on the heap. So this basically creates an array with maximum size number of elements on the heap, and this the pointer returned by the new operator, that pointer is basically stored in this element. Okay, so sorry, this element basically refers to the first element of the array that is created on the heap, okay, and that is used to store the elements of the list. So the address of the first element, it is stored in this array. Okay. So if we have to access the array, so we use basically this pointer to access the actual array. And length is equal to 0. So when a new list is created, it does not have any element, so its length is equal to 0. So this makes sense. This function, this is basically implementing the find operation. What does the find operation do? So the find operation returns the kth element in the list in this particular variable. Okay. So what does it do? So first of all, it checks whether k is a valid value or not. Okay. If k is less than 1 or greater than the length of the list, then that means you are finding for something that is not in the list. So you return a false value. Otherwise, we set x to element k minus 1. Okay, so we access the kth element using that formula. So I hope you remember this formula. The ith element in the list is at position I minus 1 in the array. So the kth element in the list is at position k minus 1 in the array. So this is how you return that element, and you return true. Okay, so you could find that element, and the value of the element was returned in this variable, this reference that you got. Okay, so it was returned here. So I hope like this is easy and it makes sense. Then the search operation. Now what does the search operation do? The search operation, it gets an element, so it may be some value. Okay, now you have to search for this value in the list. You have to search for this value in the list and return the position if it is found. We have to return the position if it is found. So where do you start? Okay, so we have to start from say we start from I is equal to 0, and we go from to the length of the list. Okay, so what do? We now, why do we do it like this? And we do it like this because we what do we do? Uh, because we are searching for this element. Which element? This element. Okay, in the array. So the array starts at index 0. So you start looking for the first element in the array, then the second and the third. If you find any element which is equal to x, then you return the index of that element. Okay, then you return the position or index of that element, which is one more than the value of I where you found it. Okay, so again it is that formula. Okay, if अगर kth element है in the list, so it is at index k minus 1 in the array. ठीक है, so this is array and this is list. Similarly, if we have ith element in the array, so in the list it is basically at I plus 1. It is at position I plus 1. सो हमने at position I in the array we found x, so then we have to return I plus 1. That would be the position of this element in the list. ठीक है? So I hope it is not that complicated. अच्छा जी. So this is how you search for it. Now this is the delete operation. You need to understand it. This is slightly complicated. ठीक है? थोड़ा सा complicated है. Complicated in the sense that you have to move data around after you delete something. Now how do you carry out deletion? Deletion करेगा क्या? So delete states that delete the element at position k and return it in this particular variable x. So delete the kth element if it exists. So first of all we need to make sure that we have the kth element. So उसके लिए क्या करना है? We will call the find function. The find function returns a boolean value, true or false. So if we have the element, the kth element exists, ठीक है, in the array, in the list. So हमारे पास we will get a boolean value. This would be true, and the value would be returned in the variable x. ठीक है. So if this is true, then this code will be executed. फिर ये code execute होगा this one. ठीक है. So assuming कि वो element exist करता है, ठीक है. So then find would return true and then we would enter this loop. पहले यहाँ समझ लें. Say for example we want to delete 2, ठीक है. हम 2 को delete करना चाहते हैं, ठीक है. We want to delete 2. So what will happen if we want to delete 2? So once we delete 2, ठीक है, we have to, यानी जब 2 डिलीट हो जाएगा तो नई जो लिस्ट है वो फिर यूं होगी 5 4 8 1. ठीक है. वी हैव टू मेंटेन दिस ऑर्डर. सो इसका मतलब ये है कि ये जो एलिमेंट्स हैं 1 8 4, इनको हमने 1 1 पोजीशन वी हैव टू शिफ्ट देम हियर टुवर्ड्स दिस पोजीशन. ठीक है. वी हैव टू डू दिस शिफ्टिंग. सो दैट इज द डिफिकल्ट पार्ट ऑफ डिलीशन. अदरवाइज डिलीशन यानी आप 2 को डिलीट करने का मकसद क्या होगा? ज़ीरो भी नहीं सेट कर सकते. ज़ीरो डजंट मीन कि ज़ीरो कैन बी अ वैलिड डेटा एंट्री. सो डिलीशन मीन्स कि वी हैव टू लाइक गेट रिड ऑफ दिस वैल्यू एंड ओवरराइड इट विद दीज न्यू वैल्यूज़. ठीक है. यानी इन नई जो रिमेनिंग जो वैल्यूज़ हैं इनको हमने शिफ्ट करना होगा so that they occupy this empty position in the list. So 4 जो है वो फिर पोजीशन नंबर लिस्ट में पोजीशन नंबर 2 पे आ जाएगा, 8 3 पे, एंड 1 जो है वो पोजीशन नंबर 4 पे आ जाएगा. ठीक है. So that has to reflect in the array as well. ठीक है. Now how would that happen? Look at this code. So if we can find the kth element, so what do we need to do then? Then we need to do this operation. What is this operation? कि we'll start from the kth element. So kth element को हमने delete करना था, 2 को हमने delete करना था. ठीक है. तो हमें 2 मिल गया. अब हमने क्या करना है कि हमने यहाँ से start लेना है, ठीक है, और जाना है till the end of this list, and we have to do this copying. We'll copy 4 in place of 2, ठीक है. Then we'll copy 8 in place of 4, and we'll copy 1 in place of 8. And that is what this array, this code does. So we start from I is equal to k. ये हैं array की जो indexes हैं, and we'll go up until I less than length, and I will be incremented. And what are we doing? I minus 1 को we are replacing with I. So I is equal to k से हम start ले रहे हैं. So I is equal to k. k क्या था? फर्स्ट की लिस्ट में k was 2. So हमने सेकंड एलिमेंट को डिलीट कर लिया. ठीक है. डिलीशन इस तरह से नहीं होगी कि हम उसको फिजिकली डिलीट कर रहे हैं. डिलीशन इस तरीके से होगी कि वी आर ओवरराइटिंग इट विद द नेक्स्ट वैल्यू. सो k I जो है वो उसकी k है 2. सो I minus 1 क्या है? 1. सो वी आर रिप्लेसिंग 1 विद I which is k 2. ठीक है. सो हम 1 को रिप्लेस कर रहे हैं विद 4, यानी इस वैल्यू को वी आर कॉपिंग 4. पहली जो इटरेशन इस लूप की होगी तो उसमें ये सूरत हाल हो जाएगी 5 4 4 8 1. ठीक है. पहली इटरेशन इस लूप की ये होगी. नेक्स्ट इटरेशन में क्या होगा? नेक्स्ट इटरेशन में ये होगा कि आई जो है वो इंक्रीमेंट हो जाएगा, तो इट वुड बी के प्लस वन, ठीक है, यानी आई वुड बिकम थ्री। तो नेक्स्ट लूप में हम क्या कर रहे हैं, थ्री एलिमेंट थ्री माइनस वन विच इज़ टू, उसको हम ओवरराइड कर रहे हैं विद एलिमेंट थ्री, ठीक है। सो वी आर ओवरराइडिंग, नेक्स्ट इटरेशन में ये हो जाएगा फाइव फोर, फोर would be overridden with 8 and we'll have 8 here and then 1. उसकी नेक्स्ट इटरेशन में फिर क्या होगा, 5 4 8 1 1, फिर ये लूप खत्म हो जाएगा। और इस लूप के निकलने के बाद हम क्या कर रहे हैं, वी आर डेक्रीमेंटिंग द लेंथ ऑफ द लिस्ट। सो वी आर सेइंग कि लिस्ट में ये आइटम शामिल नहीं है। सो इट वुड रिमेन इन द अरे, ये अरे में रहेगा लेकिन ये लिस्ट का हिस्सा नहीं होगा, ठीक है। So the list is now up until here. This is what the list is. Sorry, here. Okay. This value is here, but it is not part of the list. So the list size is 4 now. And then we return this. This is basically pointer to this linear list. So इसके return करने की ऐसा ज़रूरत नहीं है, but if you want to print the new list, so you can do it directly. ठीक है? अच्छा, और जिस एलिमेंट को हमने डिलीट किया तो उसको हम यहाँ x में उसकी वैल्यू प्रोवाइड कर रहे हैं बाय यूजिंग द फाइंड फंक्शन। सो फाइंड के एलिमेंट को फाइंड करता है, उसकी वैल्यू x में प्रोवाइड कर देता है। सो x इज ऑलरेडी मॉडिफाइड, ठीक है। सो दिस इज हाउ द डिलीट ऑपरेशन वर्क्स। द नेक्स्ट इंपॉर्टेंट ऑपरेशन इज द इंसर्ट ऑपरेशन। इंसर्ट ऑपरेशन में भी वी हैव टू डू सम शफलिंग ऑफ डेटा. So what does the insert operation do? Now in the insert operation what we do is insert x after the kth element, ठीक है। So you specify two values, you specify k जिसके बाद हमने इस element को insert करना है, and you specify the element, ठीक है। So for example यहाँ पे हम क्या कर रहे हैं, 7 inserted at element 2, यहाँ पे so this is the 1 2 3, ठीक है, सॉरी k इज इक्वल टू 2 हमने स्पेसिफाई किया, यानी 2 के बाद, तो 2 के बाद जो पोजीशन बनती है वो 3 बनती है। सो एट पोजीशन 3 वी आर इंसर्टिंग दिस न्यू वैल्यू, ठीक है, एट पोजीशन 3 वी आर इंसर्टिंग दिस न्यू वैल्यू। अच्छा, बट उससे पहले हमने क्या करना है, अब इस पोजीशन पे तो ऑलरेडी एक वैल्यू है, क्या वैल्यू है, यानी बिफोर दिस इंसर्शन दिस इज द सिचुएशन ऑफ द लिस्ट, 5 4 8 1, this is the list before the insertion of 7, ठीक है, and we want to insert after 4, 4 के बाद element at position 2, उसके बाद we want to insert 7, तो 7 के लिए जगह बनानी है पहले, ठीक है। इसका मतलब ये है कि 8 और 1 को पहले मूव करना है, शिफ्ट करना है here, ठीक है, 8 और 1 को शिफ्ट करना है पहले ताकि 7 के लिए जगह बन सके, तो वो शिफ्टिंग यहाँ पे हम कर रहे हैं, ठीक है। कैसे कर रहे हैं, सो आई स्टार्ट करता है फ्रॉम लेंथ माइनस वन, सो लेंथ ऑफ द लिस्ट इज से 4, लेंथ ऑफ द लिस्ट इज 4, सो आई की इनिशियल वैल्यू है 3, ठीक है। सो आई स्टार्ट्स फ्रॉम 3 दिस पोजीशन, ठीक है, यहाँ पे इनिशियली 1 है, आई स्टार्ट्स फ्रॉम 3 दिस पोजीशन, तो यहाँ पे 1 है ओरिजिनल लिस्ट में। सो व्हाट आर वी डूइंग, एलिमेंट आई प्लस 1 इज इक्वल टू एलिमेंट आई, तो इसके बाद जो जगह है वहां पे हम इसको कॉपी कर रहे हैं। सो द फर्स्ट इटरेशन वुड डू दिस थिंग, आई यहाँ पे कॉपी हो जाएगा। सेकेंड इटरेशन में क्या होगा, 8 जो है वो यहाँ पे कॉपी हो जाएगा इसकी जगह। सो सेकेंड इटरेशन में वील हैव 5 4 8 8 1, ठीक है, एंड देन वी आर डन। क्योंकि आई जो है वो ग्रेटर देन और इक्वल टू के अगर हो जाए, तो लेंथ इनिशियली 3 थी, तो पहले वो 3 स्टार्ट हुई, फिर 3 माइनस 1 2 हो गई, ठीक है, और फिर 2 माइनस 1 1, सो ये 2 मरतबा सिर्फ ये लूप चलेगा, दिस लूप वुड एग्जीक्यूट जस्ट ट्वाइस, ठीक है। अच्छा, वंस दिस लूप हैज एग्जीक्यूटेड व्हाट डू वी डू, एलिमेंट के इज इक्वल टू एक्स, सो जो के पोजिशन है वो खाली हो गई है, केथ पोजीशन के बाद हमने करना था, लेकिन अरे में जो केथ पोजीशन है सो वो खाली हो गई, खाली इन द सेंस के उसकी ये सूरत हाल है 5 4 8 2 1। सो अब यहाँ पे इस अरे में index k पे we can store the new value. ठीक है, so this would be overwritten and 7 would come here. ठीक है, and once we insert a new element we modify the length of the array and then we return a pointer to this array. ठीक है, so this is what we do. This is how insertion takes place. Acha, now you might have noticed that when we need to delete something from this list or when we need to insert something into this list, we need to do plenty of moving around. ठीक है, यहाँ insertion में भी आपने जगह create करनी होती है और यहाँ deletion में भी आपने जगह create करनी होती है. ठीक है, so for example if you delete the first element in this array, अगर आपने इस sorry in this list, if you delete the first element in this list, then all the elements in the list have to be copied or moved one position from their original position. ठीक है, and similarly अगर आपसे कोई कहे कि जी insert an element after the first element in the list, k is equal to 1, तो फिर लिस्ट के तमाम आइटम्स को आपने एक एक पोजीशन डाउनवर्ड कॉपी करना होगा. So if the list is small, maybe it's not that big a problem, but if the list is big, तो फिर it would take 1000 elements की list है, तो then you have to copy 999 elements. यानी you have to copy those elements one position away from their original position. ठीक है, so that is something that is very slow. ठीक है, ये ज़रा slow है, इसमें time लगेगा आपके system को in order to do deletions and insertions. ठीक है, this is one problem. The other problem is कि your list जो है it is using an array for storing the elements. An array is the size of an array is static, like you cannot change the size of the array at runtime dynamically. So that means that if the number of items in the list they exceed the maximum number that you have specified, the size for the array, so then you'll need to resize your array. ठीक है, for storing the elements, and resizing is also an expensive computation. You have to create a new array, copy all the elements from the old array into that new array, and then destroy the old array. Okay, so that is what it takes. अच्छा, this output operation, this is basically for printing out. So printing out के लिए last भी नहीं है कि we use this same code. You can simply, without specifying the output stream, you can simply print it to the console output stream, the standard output stream. ठीक है, and you don't need to specify any output stream. You can call this function as output or print. You can name it any way. But you can use the standard console output stream. You can use that for printing the list. अच्छा जी, I guess we didn't look at the destructor. I'm not sure कि destructor यहाँ पे था या नहीं. So in the destructor, this is the destructor basically. So you have to use the delete operator, the array version of the delete operator. ठीक है, so this will delete the array from the heap memory. ठीक है, this is what the destructor would do. अच्छा, now this is one big problem with array based implementation. The problem is that we might run into situations where we might need to change the size of the array that is used to store the list. The list is different thing, the array is different thing. ठीक है, so the list is the interface that you want to present to the user. You want the user to believe कि वो एक list में काम कर रहा है. Behind the scenes you are using the array to create that impression. ठीक है, now sometimes you will be very good at creating this impression if you specify a reasonable size for the maximum size of the array. ठीक है, a reasonable value for the maximum size of the array. You would be very good at creating that impression. But if that size is not that prediction for the size of the array, maximum size of the array is not very accurate, then you might run into problems and you might need to resize your array. So how can you change the length of a one-dimensional array? So the way that you can do it in C++ is that you have to create a new array. Okay, you have to first create a new array which is larger than the previous array. Okay, I'm using this writing with my mouse, so that's why it's very messed up. So you have to create a new array. You have to copy the old array into the new array. So I'm just writing copy here, and then you have to destroy the old array. Okay, destroy the old array. So these are the steps that you will be using to change the size of the one-dimensional array. Okay. When would you need to do this? You might need to do this when the number of elements that you'll need to store in the array in the list that exceeds the maximum size that you specified for the array. Okay. So the array based implementation, it has its advantages. It is efficient in, especially in finding data or searching for data. It is very efficient in that, but it is very inefficient in terms of memory. Like if you have fewer items in the array, you are using very little of the array and you are wasting a lot of memory. But if you have more elements that need to be stored in the list, then you have to resize your array, and that would take some time. Okay. So this is all about the array based implementation of lists. If I have time for this, I will do this implementation, rewrite this code that we showed in these slides, but the code is there. You can write it in code blocks and test it. That would be a good exercise for you. Okay. I'll definitely implement the linked list implementation of the linear list. So that will be the topic for the next lecture. So until then, see you. Allah Hafiz.